run it through right up the past. I'll have Hitarth explain like the real nitty-gritties of the whole product. You can go right through it.
Thank you. So I just want to ask a question from you guys. Have anyone of you guys tried to run a language model by yourself? Go to Hugging Face, load it up on your GPU, CPU, whatever. Like, how many of you? Just like give me your, I guess everyone. So that's a good thing. But you might have seen by just naively going on Hugging Face, just loading a model, it's just very slow. It's extremely slow. And the reason is that Hugging Face by in itself doesn't really support KV caching. It doesn't have the kernels like paged attention or whatever that you guys might be aware of. I hope you guys are aware of that. And I'm just going to give you a small video of how does it look like to implement inference with and without KV cache. So you can see that using any inference engine that has KV cache, it runs really fast. So while designing Tandem VLL or like the Tandem inference stack, we really wanted to make sure that the inference runs very fast. So that's the first step that we decided to use. We all know what VLLM is these days. VLLM is an open source repository that's made by folks coming out of UC Berkeley. Everyone in the world uses them. The idea behind VLLM is that they provide the state-of-the-art throughput by implementing efficient KV caching strategies using paged attention kernels. And the best part is they can run on NVIDIA, Intel, and AMD GPUs. The philosophy of Tandem is that no matter what the GPU is, we want to make sure that we basically take the pain of you to identify what GPU is, be it an Intel, be it an NVIDIA, there are different tiers of NVIDIA GPUs. We want to take that abstraction away from you. And we can see that, VLLM has, blazing fast throughput. But the problem is VLLM just supports homogeneous GPUs as of now. So let's say if you want to run an inference on, hundreds of GPUs using VLLM, they all have to be the same kind of GPUs. They all have to be the same make of GPUs. There's no way you can support heterogeneous GPUs for now, till we made it. So introducing Tandem VLLM stack, which is fully open source. So what we do, we take a large language model, we slice and dice it into little pieces, and there's an orchestration layer that we have made that provides each of these GPUs with the layers they're required to run. Using PyTorch hooks, we take the hidden states from one GPU, pass it on to the next, and it goes on and on till you actually get the tokens that you want. So that's what we have achieved so far. So there is something that comes with these inference engine, that's KV caching. So we allow the KV cache to be evicted from the GPUs by themselves using something called as LM cache. What LM cache does, it takes the least frequently used KV cache pages and it evicts it out of the memory onto a remote server or on these tiers of memory stacks. First would be the actual GPUs. The second would be the CPU and the local RAM of your system. And the third would be a remote cache storage like Redis or your actual hard drive of that instances. So LM cache basically compresses them and just throws them out. So our Tandem plus VLM plus LM cache can actually enjoy a really fast speed up as compared to just using VLM. And now I'm going to have Shwin talk about how did we design our networking protocol, which is again fully open source.
Yeah. So hi everyone, I'm Chen Hao. I'm one of the engineers with Tandem. So considering we're talking about distributed systems here, running across different machines and different GPUs, a very natural question that arises is what about the network, right? How do you connect the different GPUs? So to do that, we kind of came up with our own networking library, which is TensorIO, and it's built on top of this protocol called HackWeek. I'm not sure whether you can see it here. It's called QUIC HackWeek. So you probably have heard about things like TCP, IP, UDP. These protocols are about as old as the internet itself, older than my mom. So like HackWeek is like the new one. HackWeek came out in like about 2014, made by Google, which is about 11 years ago, 12 years ago. But in the kind of networking world, that's like the latest technology, bleeding edge, right? So we're using HackWeek, and all of these GPUs run in the data centers. So they already have very strong kind of networking backends, like backbones. So like they run between the different data center TCPs across the Amazon's or like Google's own like data center wide area networks, and they're all connected by high-speed kind of pipelines like fiber optics and things like that. So HackWeek, in a way, using HackWeek allows us to kind of maximize the bandwidth that we've been given, kind of get the lowest latency between the GPUs and the highest throughput. It also has a lot of the kind of nice quality of life improvements over the old protocols like TCP. So for example, like when you're moving between different connections, when your IP address changes, when you're connected from one Wi-Fi access point to another, HackWeek helps you maintain a connection so that you don't get dropped. So that's kind of the protocol stack that we're building on to build our networking connection between different GPUs. In fact, the code is open source as well. It's written in Rust, and you can actually install it through pip install TensorIO. That's our Python bindings, and kind of you can try using that inside your Python code as well. Yeah, so overall, this is kind of the big picture that we're trying to portray here. So you have all the different users, and you have different requests for different models with the kind of different speeds demands that you have. It goes through our orchestration system, which will choose what GPUs to deploy on, what models we have, and like what instances to run it on. And overall, it'll run it on the different chains that we have connected by the networking library that we've made, and then it will give you the inference output. So the goal here is that we're trying to give you the best performance being things like the speed to your first token, overall like generation throughput, and for like the lowest price. So the last thing that I wanted to briefly mention is that kind of the company Tandem believes strongly in open source. So all our code base, including the TensorIO networking library, as well as our VLLM kind of extended engine, fully open source. We're still choosing an open source license, but if you go to our GitHub right now, you can see the repos, you can see the code. Yeah, feel free to take a look at it, use it. If you can find vulnerabilities, that's even better. We don't have a bug bounty program yet, right? But if you come show us one tomorrow, maybe we can give you like a donut or something, or two, right? So yeah, go on.
How many vulnerabilities?
For an interview, you wanna answer?
One.
One vulnerability.
The one that we already know, and we'll put our own issues.
Yeah. So yeah, feel free to take a look at the code. So also this is the website, I think. Yeah, so the website kind of links to our docs and also kind of our API playground. So we're kind of giving unlimited credits for the next 2 days in a way. So I think when you create an account, you get $20 worth of tokens. And then if you run out, just come to us at our booth. It's kind of like an ATM for more tokens, and we'll give you more credit into your accounts.
Just come to us. I'll do the rest.
Yeah, and we're sponsoring one of the prize tiers. So for the best project that uses kind of our APIs. So now Hetal will kind of run you through a demo of how to use the things we have.
So yeah, so we've given you the API. Let me just give you a rundown of our website and how do you actually use it. So if you go to tandem.com and just click on try us, it'll take you to our portal, api.tandem.com. So we already have 4 models that we are running right now for HackMIT. There will be more that's going to come very few in the next few weeks. But for these 4, they are made for different tasks. As we all know about DeepSeek, DeepSeek is one of the best reasoning models out there. So if ever in your task tomorrow you want something which is mathematical, which is coding or anything intensive that it needs, you can use DeepSeek. Other than that, we have Qwen, Devstral. Devstral is a model made by Mistral that's really good for your code generation and everything. And then there's a general purpose Llama 3.3 70B Instruct, which Mankirat was actually using for the batched inference that he's going to just show in a while. So as you can see, I can just go directly to try and playground. It just takes me to a chat conversation that you're very familiar with these days. I know you guys use ChatGPT to make your assignments. I know that. So as you can see, if I go to DeepSeek R1 Distill Llama 70B, you can see that it's currently loaded on 4 GPUs. And this is a typical heterogeneous GPU setup that we have over at Tandem. So we can see there are 3 L40s on which we have 23, 23, and 22 layers loaded. However, we also have an A10G, which is a different GPU altogether, and our Tandem orchestration layer takes care of that. And I'm just gonna type a prompt. Shwen, you were talking about a nice sort of a thinking prompt.
So I found out that at MIT a few years ago they somehow made a fire engine or some dome. So
I mean, ask it. What's the fire engine on of the dome at MIT? Does that sound good? Okay, let me just click Yeah, and you can see that these layers are currently working. They're connected to our backend, and the thinking is currently happening right now. I remember seeing some pictures of MIT's campus, so I guess that's it. So as it finishes thinking, I can show you another, page for trials. And I can just give you a demo on how do you actually get your keys. So as you can go to the models, you can just see, whichever model you want to use. There's a curl. You can just feel free to copy it, use it in your, coding prompts and anywhere else that you want to use. You also have Python and Node.js examples, which is, the basic stack that you guys would probably be using. And you can, if you want to actually generate a new API key, you can just come up here and create a new key called production or test or something, and generate the key, copy it. And after you copy it, you can just go back to the models, and you can just change the bearer token with the key that you just created, and your API will end up running. We also provide metrics on how many tokens that you have actually used, what's the total amount of requests that you have done per model. So you can see that this is my account. I've been just experimenting with this, and I can see you can see the total number of tokens. It gives you a nice rundown on the amount that you have actually spent with Tandem. And in case you want to, get more money, trust me, guys, just come up to me tomorrow. It'll be fine. I'll get you more. But even if you want, you can, just add more money, and, it'll be taken care of. But we can see that it just provided you an answer, which is something. But yeah, I think this was it. Yeah. So the fire engine on top of the MIT dome is part of the tradition too of elaborate pranks by MIT students, known for their creativity engineering skills, similar to the 2013 police car prank. Oh, I see. Anyways, I'll head it back and give it to Mankirat in order to show you guys the result of the batch conference that we started.
Yeah, I'm not sure if it'll be fully done, but tomorrow we're gonna be hunting you guys down to see if you guys are using the key, and if you are, you'll get a bunch of cool swag. But I think the inference will be done by then. I just wanted to show you guys some of the metrics that the inference will have. So in the batch we ran English to French, we ran around 60,000 different tokens, and on leading providers like Together AI, Databricks, etc., you're expected to spend just 6 to 7 cents. Well, that's because we just ran 60,000 tokens. A lot of big companies, they're running millions or billions of tokens every single day to see, like YouTube runs, if any, like, what's it called? Moderation is going through, stuff like that. But with Tandem, you're automatically going to get 30 to 40% reduced cost. And that's just because we can leverage these spot instances and connect everything together in a way. The runtime runs in a way that it'll be the best price to performance ratio. You guys can also click on our website and GitHub if you guys want to leave a star. That's also very appreciated. I'll be checking for stars tomorrow as well. That'll give you the right for more merch and some donuts. But yeah, we're really thankful to be able to give them the opportunity to present this to you guys. Actually, this is our first launch. Like, no one's used the product before this. So tomorrow a lot of people will be hitting us. We'll see how it goes. We're excited to, make it better. I think in just 3 or 4 weeks, the version 1 will be coming out. Right now it's version 0. That's on production. But yeah, excited to hear what you guys think tomorrow about the product itself.
Also, feel free to grab these rings. There's like stickers on all of these benches on the extreme left-hand side for you guys. Feel free to use them. Tomorrow, please do come to our booth. We have lots of merch for you guys. And anyone who wants to ask any questions, really appreciate it. Sure, good.
So, just curious, these technical questions are back.
No issues.
Why I will, because I love Apple, I'm just wondering if you name that Uncle Ivy.
I'm sorry, I'm named it after.
Why I will?
Ira? Ira is actually not named by us. It's a different company that used the Quick protocol to make Ira. They're very decentralized type of people.
But I think I know what the question you were asking. So when I used to search IRL, there used to be an Avatar anime that used to come up, and there's probably some character there. So yeah, now I kind of know.
Maybe that's why.
It's coming full circle now.
The guy's name is Brian. We can ask him.
Yeah, we have a collaboration with them.
Sure.
we have like 5 deviations for tomorrow.
You can delete a new. You can
You can
delete
just
a key and get a new one. You can ask me for more keys.
You can
That's
create more accounts.
you can create more accounts.
Yeah. Limited key.
Right.
Just like, I guess, this question of like being a startup, like, do you guys worry at all about like competitors, given this, like, you're just deploying this now and like it all being open source and things like that? Do you worry about competitors at all?
The base stack is open source. That's like saying like Databricks should be worried because
Okay.
their Spark is open source.
Yeah.
But we do make it frictionless for the people to use the keys. It's very there's no friction involved. You just click and you'll get the key. Also, the orchestration layer behind how everything is routed is proprietary. The base stack for running the thing is open source. If you guys want to figure out the orchestration yourself, feel free to.
Because the problem is finding out the cheapest spot instances, then making sure that the models are correctly loading on them, then making sure that spot instances can just die in seconds. How do you have one backup ready at the exact time that you want? And you as an end user will not see the interruption of, your inference running. That's the hard task, and that's why it's proprietary. So yeah.
But we will publish a lot of papers on it. So
I have a question. I'm not sure how deep it is, but how long did it take to actually develop the entire orchestration stack? Like I'm sure it is very complicated.
we're still working on it. It's very beta. We've been working on the whole project Tandem as a whole for about 8-9 months now. We come from research backgrounds too, so that helps quite a bit.
So
But-
it started with like having a Hugging Face sort of a backend instead of having a VLM backend, because Hugging Face is much more hackable. You can just extend those libraries. It's very friendly. But then we realized that using PyTorch hooks with VLLM can make us really, really faster, and orchestrating them together, finding the spot GPUs and everything. So that took us like at least 3 or 4 months. We've been developing this after we were done with the Hugging Face sort of a backend. We shipped it fully to now VLLM.
Just to put in a picture how hard orchestration is. So there's maybe like 50 plus cloud providers out there. Each cloud provider has a couple of different types of GPUs, 20 to 30 different types of NVIDIA instances, 5 to 10 types of AMD instances and TPUs. On top of this, you want to find out which region they are in. And there's multiple regions across the world. After you find out all the GPUs available in the world, you want to see what the latency would be, connecting from the user, which is sitting in Boston, maybe something in Asia Pacific. Based on that latency, you want to see what type of model you want, how to split the model. There's like 5 different types of parallelization strategies that you can do. So the variables just keep on adding up and adding up. But it's pretty hot research topic right now. UC Berkeley is taking a big part in it as well.
Yeah.
We're working with those guys.
We actually live in Berkeley.
We live in Berkeley.
Yeah, and we're from San Francisco. Like we work there. So yeah. And we are actually looking for interns to join us anytime. Like full stack, we need help in ML systems. If you guys are comfortable or you're graduating, we are also on the lookout for full-time opportunities. We just closed our seed round a while ago, so yeah. If you're excited to come and build an SF,
Come to the booth tomorrow.
come to the
Yeah.
booth tomorrow. Actually, yeah.
Like just like I'm not too familiar with the field in general, but like as you are, I guess, building these different hardwares together, how do you also how do you balance that with the software in the background? How does that work together?
So the general vision of Tandem is to abstract away the hardware layer from the application layer. So we're a middleware that gets rid of the need to look at the hardware for these software applications. We put our application on top of the hardware that will, take in the model charts, or if you're different type of modalities, different trainings, it'll split them across different pieces, and we would stitch them together on the middleware that for the software level, it's very easy. So the general thing is, back in the day when CPUs were a thing, it was most of the systems were homogeneous. Now the systems are very heterogeneous. There's many different types of hardware you can run things on. It's actually very hard to find homogeneous GPUs. So we want to build a runtime that can be distributed for these heterogeneous GPUs, and the software developer doesn't have to care about it at all. That's the broader vision.
Yeah.
Hopefully in a couple of years we'll get there, but we're working on it. Yeah. Any other questions? If not, then let's get over it. Okay. Where are you guys from? I know some people from Germany. Mexico.
Mexico. Oh,
Okay,
wow.
okay.
Argentina.
Argentina.
Oh, wow.
Okay. That's insane.
I like yerba mate.